Well, hello there, happy campers. We're here to do the Gang of 4 design patterns in Perl. We're going to start off with the factory pattern. What I've done is I've taken a lot of my lead-in from Tutorials Point. They have a lot of good tutorials that are out there. The one, of course, I'm interested in is going to be the design patterns. Some of these slides are taken directly from this factory pattern. If this goes well, I'm going to be walking each one of these patterns and how we're going to do them in Perl. And it's not just a direct line-for-line translation, but it shows you some of the features of Perl that over and above Java and C++ that make the object-oriented design far better, I believe, and far easier and far more flexible. Of course, Java experts will disagree, and I welcome that. I would love to see a head-to-head comparison on how, well, obviously how this is already set up, but when we get to the part of making changes, for example here, how difficult is it going to be to add a triangle? How difficult is it going to be to add different steps to some of the stuff here is like for the draw, the circle, they got a circle, square, and a draw, and we've got other things here where we're doing just a draw. There's going to be an animate and so on and so on. Well, of course, let's get to that later, but in the meantime, I just wanted to point out that many of these slides are going to be coming from this site. So, without further ado, here I basically describe what the factory pattern is. Probably the best bet is to go straight to the class diagram. What we've got here is and this is again right from the site. We've going through creating. This is the driver script in the Perl world where I'm instantiating a shape factory, and then in turn I'm instantiating one of the actual shapes that are out there. And each of these shapes have got a method, just one method for now, called draw. And all we're going to do in this particular case is just effectively do a print so that we can tell that we hit it and we got the correct thing going. So the steps that we are going to use to create this factory pattern, we're going to create that driver script, or at least pieces of the driver script, and build that up as we go along. We create our abstract classes, our concrete classes, and then the factory class to instantiate the selected concrete class. I'll go back to the diagram. This here, as I've pointed out here, there are no interfaces in Perl. What we have are abstract classes, and we use abstract classes as Java would use an interface. And then here is our shape factory, which will get instantiated. We'll then call this getShape, which will have the name of a parameter, which will have either circle, square, or rectangle. And so that'll create that object. And then when we call that object, we can then call the one method that it has, the draw. And these ones here on the bottom, they're called concrete classes because you can instantiate them. The abstract are typically used for inheritance, for sharing common behaviors, much along the same definition that interface was. So let's go at it. We're going to create a file, and we're going to call that factory demo.pl. And we're also going to open up our debugger in another window. I use Linux. I'm using Windows for my Vim, plus a VM in Linux with a Samba mount, and then I run on that. I like using the debugger on Linux because I could restart it. I cannot do the same on Windows. If somebody has a way of doing that, please let me know. And I could conceivably get rid of the Linux link, but for now, that's how it's set up. So we stub it out. I know based on my class diagram, I'm going to need these classes that are out there. I throw the double DB single in there because if it's just one, if it's a DB single, they're breakpoints. And if those breakpoints happen with another line after it, you can get away with one. But if it's the very last line that's in your script, then you need to have two. So we run the script, we go through, we see what the output looks like from the debugger. Nothing to see here, but what there is that there's no compile errors. So we're good now for the next part. This, of course, is where we build it out. First off, I've got these kind of cockeyed, the order of it. The source that we're going through is we're now going to build out our shape factory. And here's our instantiation that's going here for creating the shape factory object. And here is where we tell it what shape that we're getting. Object-oriented programming, this is called polymorphism. We have one function given a parameter, and we could have different objects come out of it. Effectively, that's what the factory is going to be. But as you'll see here, this model is really a factory of factories, and I'll explain that in a second. We are then going to have a shape method that we had going back to here. That's this guy. That's the abstract. And when I go back to here, I know I've got a constructor that's sitting here. I don't know if I'm breaking any rules by doing that, but these guys are the concrete ones that are going through. And the reason I'm doing that, they've all got the same constructor. We could change that. I could bring this guy down. Anyhow, I'm not going to confuse things anymore. I'm going to leave it like this, where that now we've got our shapes, and then we've got our 3 different shapes that we're going to be creating. And here's a driver script that's down on the bottom. Instantiate a shape factory, call it O shape factory. I've got in the habit of, I don't know what kind of Hungarian notation it is, where that my first character will be a lowercase a for an array, a lowercase c for a character, lowercase d for a date, O for object, n for number. That's it that I can remember right now. If it's a reference, then I'll have an RA or an RH. It's very rare I reference anything else. Yeah, that's it. That's it for the notation that's there. Of course, your mileage may vary. And when running this script, that is what we're doing right here. And as you can see here, here's the output. The only thing that's output is the draw circle. So that's telling me that that's this line that's right here. So it's working the way it should. If I take a look at the objects themselves, there's no data. O-shape factory is, believe it or not, shape factory. And O-shape is not of the type shape, but it is of the type circle. And that is happening because of the inheritance. We've got this if ladder that I've alluded to that, yes, we're going to refactor that out. But for now, when we run it, it's working. So we then get to, wait for it, the next step, refactoring. So what I've done here is, remember that ugly if ladder that we had? One of the beauties of I guess any language, but certainly with Perl, is that we can do things like dispatch tables. And here I've given an entry in our hash table, this 8 shapes, each one of the shapes that we're going to have. And if it's in that list, then what it's going to do is it's going to have an anonymous subroutine attached to it. And that sub is basically just instantiating an instance of it. So what's that buying us? Separates the data from the code. Again, always a good thing to do. We always strive for that, because as we add shapes, all we need to do now is add an entry to these guys here. So if we want to add a rhombus, if we want to add I don't know if I want to touch this yet, but a sphere or a cube or any of those kind of things, then I would add shapes here. I'm going to probably need a different class to do 3-dimensional stuff, but any other 2-dimensional shapes, absolutely. I can put them, just add the lines here, and then I run the code without any further changes. That, well, I guess what I would need to do is add another entry here, of course, for the actual code. I mean, Perl's good, but it's not that good. Which, oh yeah, I forgot. You'll just have to go work with me on these. I blew out the circle method, but the square and the rectangle, they should be right underneath here somewhere. back to get shape names. Again, we want to encapsulate any data that's in an object. We want to encapsulate that as best we can. Nobody should know what type it is. In this case here, it's a hash, but we could change that to a database. We could change that to some kind of a web link. Anything. It's not your business as you as a consumer. As a user of this method to know what it is. All you need to know is what the names of those shapes are. You need to know that you need to have a constructor, and you need to be able to get a shape based on a shape name. That's it. You don't care about anything else underneath there. So part of our driver is that we need a list of these shapes. That's it there, right? Not rocket science, but it now keeps people out of there. Again, this is Perl. If somebody wants to go in there, they can. But you know what? If it fucks up, then it's on you, right? That's not. You mess with the bull, you get the horns, right? So, anyhow, that's what we've got going here. The shape. I've taken it out a little bit further. I've taken the liberty of actually increasing the functionality. I'm assuming that I had spec already that said, hey, we need to not just draw, but we need to animate and print these shapes. So that was all that would be required to add functionality. I know in other languages, there'd be a little more involved to do that. And now in Circle I could have done like any other one, but I wanted to blow it out so that when you can override, of course, standard object oriented programming is that you can, in a derived class, you can override the base class. And that's what we're doing here. We've got the draw, the animate, and the print. For the record, animate and print, they're doing exactly the same as the base class. They could go. But draw, on the Circle side, I wanted to show that how even though we overrode the method, we can still call the parent method, right? And we could put code before, we could put code after, we could put code before and after. And conversely, if we're not putting any code in there, then there's no point of overriding the function, of overriding the method. And yeah, that's what we'll see here. In fact, as we get to the next screen, we'll see what it looks like when it runs, because this is what the driver now looks like. The first line of the driver, I'm instantiating a shape factory, so there's nothing new. Here, I get the shape names from the factory, so again, I have no idea what's behind that. I just say, give me the goods, I'm out of here. I create an entry that, based on that shape name, I then instantiate a shape object. And from that, and I've taken it that other step where rather than digging into this class, where to go? Shape. Oh, it looks like I need to. Okay, so this get actions that we have here, you're just going to have to take my word on it. It'll be in the code that you can get to on GitHub, where all it does now is it returns an array of the actions that we can do for the shape, the draw, the animate, the print. So that's that here, and then all I do is I simply call up that shape in the action, throw a blank line in between. And here is what it looks like for each shape that's going through. The circle, it's been blown out. For the rectangle, square, and triangle, nothing new that's there. They have their own. They have their methods are basically using the parent class. And again, to see that, you'll have to just assume that rectangle, square, and triangle are just one-liners, like they were here, right? That's all they're doing. And there's the actual animate and the print. They're being called from the base class. And that's it. That's basically it for the debugger. Well, that's it actually for the factory class. I've shown here that how easy it is to add functions to the shape. Right? Just simple one-liners to go through. You could override at the shape level if you need to. Chances are you don't. In this case, I didn't need to do that for circle. I could have had all four of them looking just like this. And they would have called the constructor and all these methods right from here, from that side, which I've got them sitting here. Okay, so now putting this into production. The big sin that we've got going on right now is that all methods, all classes are all in one file. It does not make for a very good sharing environment. So what we want to do is we want to take effectively our driver script, which is this factory PL, and we want to take all the classes that are in there, all the stuff that we've got here, and put them in its own separate file. And what we do, that's exactly what we're doing. We then take everything out of there, create and dump, create a lib factory.pm, dump those classes into that file. And then we run through our debugger. Okay, so what I've done here is that the only thing that's going to be in factory PM is going to be the shape factory. I've now split out all my shapes so that all that's in there is what we see in these files here. The reason I did that is that typically these guys are going to need to stay together. Certainly our shapes will, and what's getting called by shape. How this gets called from other things, it could feasibly vary. It's not a big deal now to basically break it out of this file and put it in its own file. And as you see here, I'm doing a use shapes. They're getting dumped into a lib directory, and I'm telling it how to use the lib directory with, wait for it, the use lib command. Everything else is the same. Again, after every change, just pass it through the debugger, make sure it's still working. And then for shapes PM, I'm not including anything. It's pretty much good to go. Again, run it through the your debugger to verify that that's okay. Trust but verify. Testing your code. There's a lot to talk about for testing, automated testing, and we will certainly get into that later. But here we've creating a file calling this tfactory1.t. And in that, I am going to basically do the gist of the driver. So I'm creating hold on. I am reading the factory class. I'm verifying that the class is good. I instantiate it here. I verify that the type of the shape factory is, the type of that object is a shape factory. I'm then checking to see about getting the shape names, and I'm comparing it against that array, and so on, walking through each one of these steps. This is a very preliminary test. If you were going to put this into production, you would expand these tests. Like, for example, what happens if I don't specify, well, I do have it here. If I don't have a parm for get shape, it's a die. And I can verify that it died because I didn't put a parameter in. Further, I can tell that there was no shape defined as the error message that comes back. That's what I'm expecting. And then if I put a bogus name, some name that does not exist on the shapes, I should get that error message, or at least that's an expression, regex that I'm getting coming through. And that then says, okay, we got that. I'm doing the get actions, and currently the actions right now are draw, animate, print. I compare that to the output. It's going to normally this method is coming back with an array, so I wrap an array, put it into array ref to test, because is deeply needs to compare an array ref to an array ref, and then of course doing the breakpoints. When we run it, this is the output that would come from the factory. Most of these, any of these commands that have a text description on the end is what we're going to show up. Unfortunately, I still do not know a way to show some kind of a good message to come up, because if I don't put these text messages, all you get is an OK 10. I have no idea where it came from, so on and so on. I'm sure somebody has got this, but please let me know that what you find for that. The other useful alternative to all this is running a utility called prove. I generally just do it to a test at a time, but if it's a big project, or even if it's a serious project, you're going to have multiple test scripts. And if you have them all sitting in your /t directory, it's going to run them all. And it'll get these, basically it'll run them and then come back green if every one of those tests are successful. If it fails, then you'll get some kind of an error message. And the nice thing about prove is that all tests were successful. There's a good chance you should, in your test script, have 30, 40, 50 test scripts, test lines that are in there. You don't want to see this for every one of them, right? You want to just say, oh, it's okay. You can walk away from this thing when it's all green. So if you've got, a dozen test files and each one of them is testing a dozen things, that's 144 tests, and they all come back green, you can take yourself a break. Testing your code part 2. This is one of the pet peeves that I have. Brian Foy deals a lot with this in his book, Straight Perl. And probably the best thing with this is that it's just like smoking. The best way to quit is never to start. The point here is that in your objects, do not use print. If at least if you are going to use print out a variable and return that variable, because this is what you've got to go through to try to test an object that prints out to something, and you want to test that printed value. You actually got to capture your stood out. Then I did this as a test here, just as a printing of the line, and then releasing the stood out. I'm basically telling it to print to take standard out and copy that to a variable. Pain in the ass, but yeah, that's what you're going to need to do if you've got any kind of print statements going on. Alright, so I believe this is going to be enough info for you to pull the code. YouTube, I'm learning this as I'm going, so yeah, it's not going to be elegant, but if you want this screencast, that's where it's at, or you want to watch it again, blah blah blah. And I'm dumping all the modules, including the PowerPoint, the lib and the T, all in GitHub. Yeah. Hold on. I guess basically I should be dumping this over to here. Yeah, when you do a GitHub pull, I need to find out on GitHub how I can just basically say, yeah, you want it, take it. I guess I'll find that out soon enough. If you need to, oh yeah, you can contact me at that's what I was going to put down. Email me at janman27929@gmail.com. All right, do the old Savaruni, and yeah. At this point here, yeah, I'm done. So let me know if there's anything else you're looking for. As I said, tutorial points. I'm going to be walking all 24 of those. Then I hope to get into some of the simpler things, how to get into creating databases, how to creating a simple website, practical stuff that you may not think you're capable of doing, and you can show you how easy it actually is. And yeah, all you got to do is put some time in it, put spit and polish on it. You're good to go. Anyhow, thank you for listening, and I hope to see you on the next one. Bye-bye.